In this video, I'll give you a step-by-step walkthrough to set up a powerful RAG system locally on your hardware using Python and LangChain. Why do we need RAG and AI? 1. Overcoming the knowledge cutoff. 2. Access to private or proprietary data. 3. Drastically reducing hallucinations. 4. Source verification and auditing. 5. Cost and efficiency. Required software, tools, and models. Ollama, a lightweight desktop application/background service that downloads, orchestrates, and runs LLMs and embedding models entirely locally on your hardware. Nomic Embeddings, a high-performance local embedding model used to transform your PDF document text into vector math chunks. Llama 3, the foundational large language model, LLM, responsible for synthesizing retrieved context and generating an intelligent answer. You can use other free models like Gemma 4 by changing the LLM name in the script. Python, version 3.10 to version 3.12 recommended, and Python libraries. Refer the description for step-by-step installation instructions in Windows, Mac, or Unix machines. When you install the Python libraries, check the errors and warning and fix them before you run the script. You can also check the installed Python LangChain libraries by running the command pip list grep lang. Let us install Ollama server. Ollama is one of the popular open-source LLM. Go to ollama.com, click on the download and select OS. Run the download file and install. http://localhost 11434/ should give the message, Ollama is running. Go to terminal, type Ollama. The commands are displayed. Ollama serve command also will start the Ollama server. Some of the frequently used commands are run, stop, list, rm, etc. Let us install few LLM. Go to Ollama website and click on Models. Various models are listed here with tier size, number of parameter, etc. Select Llama 3.2 and copy the instruction to install. Model will be downloaded in the local machine. It will take few minutes depending on your machine and the size of the model. When it is done, you can type some prompts and check. Let us ask, what is the capital of USA? And the model gives the answer, which proves the model is installed and working. Type / and by to exit the model. This script is a complete, local RAG, Retrieval-Augmented Generation, pipeline built using LangChain. It allows a user to point the script toward a local PDF file, automatically index it into a vector database, and ask questions about its content using completely local AI models running via Ollama. Let us do some tests using the script. We will load a project plan in PDF format and ask some questions. Go to the folder where the script is stored and run the command. Python 3 local_rag_final.py. Depending on your machine, you may have to give Python instead of Python 3. Then, give the name of the document. Let us ask a question. Who is the project manager? It should give the answer as Tom Cruise from the document. Yes, the answer is correct. Let us do one more test. What are the key deliverables for phase 3? We got the right answer. Let us review the code step by step, and then do some more tests.
Here is a brief, practical explanation of what each of these specific import modules does in the RAG pipeline. PyPDF Loader is a dedicated document reader designed to open PDF files, extract their raw text, and split them into structured page objects, keeping track of text content and metadata, like page numbers. If we are reading a text file, then we have to use the text loader.
This is the 4-page project plan PDF document we will use to test the script. PDF Loader will split and load this document. Recursive character text splitter. It handles the chunking of your documents. It smartly splits text using a hierarchy of characters, like paragraphs, then sentences, then spaces, until the chunks are down to your desired size, ensuring semantic context stays together as much as possible. Chroma. This is the vector database wrapper. It takes your embedded text chunks, stores them, indices them mathematically, and allows you to perform fast similarity searches to find the right context when a user asks a question. Ollama Embeddings connects to your local Ollama instance to translate text chunks, and later, the user's question, into high-dimensional numerical vectors, embeddings, that represent the meaning of the text. Ollama LLM connects to your local Ollama instance to run the language model itself, like Llama 3. It acts as the generative engine that reads the context and writes the final answer. Chat Prompt Template systematically structures the prompt layout. It lets you predefine system instructions, how the AI should behave, and human placeholders, dynamically merging variables like context and input before sending them to the LLM. Runnable Pass-Through, a utility tool used in LangChain chains to pass a value completely unchanged from one step to the next. In your script, it takes the user's exact query string and passes it directly to the prompt template without messing with it. str output parser, A cleanup utility. Language models usually return complex AI message objects that include metadata. This module strips all the extra data away and extracts just the raw answer string so you can print it cleanly. Step 1. Dynamic file selection and validation. It prompts the user to type in the file path of a PDF. Instead of hard-coding a file name, it makes the script reusable. It safely checks if the file exists on the hard drive before trying to parse it, preventing a sudden crash. LangChain's PyPDF loader reads the file and extracts all text content, organizing it page by page. Step 2. Document chunking, text splitting. It chops the long, continuous text of a PDF into smaller pieces, chunks, of 500 characters each. It also ensures a 100-character overlap between adjacent chunks. LLMs have limits on how much text they can process at once, context window, and embedding models work best on smaller, focused ideas. The 100-character overlap acts as a buffer to ensure important information isn't accidentally cut in half at the boundary of a chunk. Step 3. Generating embeddings and setting up the vector database. 1. It initializes Nomic embed text via Ollama, which converts text strings into a string of numbers, vectors/embeddings, representing semantic meaning. 2. It passes those text chunks into ChromaDB, an in-memory vector database, which hashes and stores those vectors. Computers can't easily search text for conceptual meaning, but they can compare vectors using math. By storing chunks as vectors, the script can later find the chunks that are most relevant to a user's question, even if the exact keywords don't match. Step 4. Loading the local language model. It hooks into Ollama to load Llama 3, which will act as the brain of the operation. This model is responsible for reading the retrieved document chunks alongside your question and drafting a coherent, natural language response. Because it runs locally on Ollama, your data never leaves your computer. You can list all the LLMs loaded in your machine by using the command Ollama list. We are using Ollama 3 in our script in Cans. If you use some other model, change the model name in the script. Step 5. Structuring the prompt template. It defines strict guardrails and instructions for the LLM. It acts as a template with two variables: context, where the retrieved PDF snippets go, and input, where the user's question goes. Without this constraint, Llama 3 would just use its general training data and potentially hallucinate, make things up. This explicitly forces the AI to ground its answers only in the facts provided in the context window. Step 6. Building the RAG chain using LCL. This wires up the pipeline using LangChain's pipe syntax. 1. Retriever. Configured to grab the top 3 most textually relevant chunks from ChromaDB based on the user's question. 2. Format_docs. Glues those 3 chunks together into one clean string. 3. Runnable pass-through. Seamlessly passes the user's exact text query straight to the input variable. 4. The chain. The data is packed into the prompt, sent to the LLM, and clean text is extracted via str output parser. Why it matters? This is the heart of LangChain. Instead of writing dozens of lines of manual code to pass data back and forth between the DB, prompt, and model, the pipe operator automates the data flow sequentially. Step 7. Execution and output. It asks you what you want to know about the PDF, passes that string into rag_chain.invoke query, triggers the entire pipeline, and prints the final answer to your terminal. Let us load a health insurance coverage document and ask questions. What is the family out-of-packet maximum? It gave the correct value for out-of-network. It should have given the in-network value also. We have to do more tuning. What is the effective date of this coverage? We got the right answer as July 1st, 2026. The RAG works as expected.
If you found this video helpful, smash that like button, subscribe for more automation tips, and hit the bell so you never miss an update. Thanks for watching, and I'll catch you in the next one. Bye. Bye.